Before I dive into the API, let me quickly introduce ourselves. My name is Bo Majewski. I've been with Google for 5.5 years. I started on a geocoding API, joined the Wave, hence you didn't see me for 3 years, and then right now I'm working on App Engine. Jed?
Yeah, hi, I'm Jed Ellis, and I also worked on Wave for a couple of years, working on search and notifications. And recently, in the last 6 months or so, I've been working on search in App Engine.
Right. So just to gauge the audience, how many of you have used anything like Lucene, Solr, Whoosh? Okay, so you're very much familiar with the reasons for doing this. Anytime you want to have something like a bunch of documents and you want to allow users to find the right documents by entering just few key terms, you would use a text search API. If you have a feed, usually it's filled with information about people eating breakfast and going to sleep, and from time to time you want something more relevant, so you would search it as well. Gmail changed the approach to email by focusing on search rather than on foldering and cataloging your email. So again, this pretty much uses a search API, text search API. And finally, every time you go to Amazon, eBay's, where you have hundreds of thousands of products, use text search API to narrow your searches. So about 3 years ago, an issue 217 has been filed, which since then somehow mysteriously drifted to number 2. And the person who filed it noted that since we are Google, we pretty much should provide the text search API. So we actually agree. It just took us a while to get to it. What I'm going to talk about today, and Jed, first we're going to present you with a core, what we call core search API. This is a more low-level approach, those who do not use Data Store directly. The second part of the talk is going to be integrating this with Data Store, how to use it with Data Store, and finally we're going to mention our plans for REST API, which allows you to exist outside the App Engine altogether. As you might be aware, what is available today, you have essentially two possibilities. You can either rely on the Data Store, and Data Store allows you to store text and strings, and you can use equality and inequality, and in case of lists, you can test for membership. Or you can do anything you can do over HTTP. So you either do a self-hosted solution, where you put up your instance of Lucene and just query it, or you go to a third party. However, this is not the most convenient thing. What Jed is going to show you is what is available right now. We actually have it working. And there is no more appropriate way of showing it than showing you with a 90s style application, the guest book you can put on your web page. Okay.
Okay, so yeah, we have a sort of guestbook application built on top of the Search API. There's 3 sections, I guess, to this demo page. There's a little comment box here where you can type in comments, a search box where you can search for comments, and then a list of search results, which is the comments which match the current search. So the current search is all comments. And then you've got some other fields here, like the author who wrote it and the date published. So let's go ahead and make a comment. So I'll be back. So we're making comments, basically just quotes from movies, and we'll hashtag it with Terminator, and I'm going to shout out to Bo. So that gets added to the index and is returned in the current search, which is all comments. So you've got the comment there, said who wrote it, so it's anonymous and published today, and you can see that it's currently signed in with anonymous, no one signed in. So let's do some searches. So I could search for simple terms like fish, so that'll find all the comments that mention fish. you can see that it supports CJK, so I can search for just the character fish. I can do more complicated searches like combinations of terms, like be back, and you'll see it'll match the comment I wrote before. Also, it's I'll be back, back to be and not to be is best quote. But if I want to actually match this, I can do a phrase query. So this is just showing some of the sorts of queries we can do that this supports. So it'll only find be back. You can restrict your searches, so I could search for things that I wrote. So you can see that, in fact, it searches for Jed in the author field. So you can restrict to, obviously, anonymous. So things that have been anonymously written. You could also search for other things like tags. So if I want to search for gladiator, oops, that's actually the wrong syntax. So tag gladiator. And so that finds all the hashtags, all the comments with hashtags in gladiator. Similarly, if I want to find out, shout outs to Bo, that will find all the shout outs. So in terms of some of the more complicated searches, so you can search for combinations with using logical operators like and or not. So here we're searching for anonymous comments that contain the word back or machete. But I can also do things like restrict it to not Macbeth, tag with Macbeth. So that shows some of the sort of, the sort of standard things you'd probably find in a search site. So some of the other things you could do are search for published ranges. So I could give me all comments that have been written up to including the 6th of May. And if I want to do exclusive ranges, use the curly brace syntax, so that excludes the 6th of May. And you can do things like delete documents. So I'll delete that comment, and now it's no longer in the index. So that's showing basically documents being indexed immediately and matching searches. There's also pagination, so I can just paginate through the results. Okay, so let's have a look at some of the code behind that and the concepts. So there's two processes in search. There's the indexing process. So for example, we're taking user data. In our case, the user data was the comment, the author, so the person logged in, the time of the date, and things like tags and shout-outs. So there's some of the fields that are added to documents. So the document would be this comment document. That document is then given to the indexer, which will tokenize it and then build the inverted file in the index. So then the search phase, you're taking user or application input. In our case, we were taking exactly the query that was typed in. That's given to a query builder, which will build a more formal query and give it to the indexer backend and execute it against the index and return a search response, which contains a set of documents. And then those documents will use a result builder and construct, in our case, the 3 little comments shown at the bottom of the page. So the architecture, so I'm going to discuss the left-hand side of this diagram. Bo is going to talk about the data store side in the second half of the talk. So the application, you construct the document, then you ask the indexer to index that document. The indexer then will write that document to Megastore, which will then tokenize it and build the indexes. An application will send a query to the indexer. The indexer will then issue that query to Megastore, read the set of results, the entities, and convert them into a search response, and then the search response is sent back up to the application. So you have full control over the document schema and content. There is no upfront declaration of the schema in the YAML file. It's actually done as you add fields to documents. So and document content can be arbitrarily transformed. So in our case, we were taking those comments and we were also extracting out the tags and the shoutouts. But it could be a product document and you could unify with that pricing data, shipping, and offers and reviews, etc. So you could build a full product page. So the typical sequence: create a document, add the documents to an index, and then use a query to match against that index and return documents or snippets. So for those who, this should be reasonably familiar, who've used Lucene, etc. So the document is a collection of fields plus a document ID. Document ID has to be unique. You may have a language specification, so you can add an indication on how it should be tokenized. And then there's order IDs should also be supplied. So the order ID is used to sort the documents by default. And you saw with the demonstration that those documents were sorted from most recent to oldest. And that's using the default ordering, which is the number of seconds since January 2011. So fields are simply a named and typed value. The name doesn't have to be unique, so you can add multiple values, so you can have as many tags as you want, for example. You can specify the language so that you can override if you want for that particular field, or you can specify this level. And as mentioned before, the schema is built as you introduce new field names and types. Some of the field values we support: plain text, HTML, so you can use a HTML parser. Dates, so up to day level granularity, and date time, so you have milliseconds. Geopoints, numeric, and atoms, so you can have fields that you don't want any tokenization and treat as a single value. So let's look at how you could create a document. Here's the Python code. So we have a document ID, set the document ID. In this case, you'll need some way of generating a unique document ID. And then you basically just add a set of fields. Let's say there was text, HTML, and dates, and atoms. We'd probably have two more here, which for the tags and the two fields. But essentially, you name each one, you type it, and you give it some value. So you have the author, which is using the nickname, comment, which is the actual text from the text box, and the date field, which is the date today. The Java is pretty similar, except we're using builders. So you just get a builder, set the document ID, and then add a field. And then for each field, you have a builder. So a field builder, you set the name, and you set the type of value it is. It's text, HTML, or date. So the index is fully dynamic. So as you add those new field names with the types, and you index that document, that will introduce that to the schema, so that'll extend the schema. We support versions. So you can have an existing version of an index. You don't need to do this, but you can. And you could build in a background process, rebuild the index, and then hot swap that index out. There's two levels of consistency supported. This is global or per document. So global is like an inbox style, and you're basically, if you're putting a label on a document, for example, like your email or something, and you put it on that document, if you search for that, you expect that document to be retrieved, so that all rights are committed up to before that search is executed. And then there's per document, which in a feed style, it's not that important that if there's other content you aren't aware of, then if it turns up a few seconds later, then that's okay. So global has, you have the same sort of, this is an issue around Megastore, and you see the same thing around Data Store. It's how it's like selecting entities. So global is basically, has around like 1 QPS of writes that it can support, but per document can support thousands QPS throughput of writes. So the sort of operations we support are index and re-index the document, search, so you can search with a simple query string or a complex search request, so you can override all the features like sorting, scoring, etc. It's delete document, so you can delete by document ID, or you can delete by issuing a search query, so all the documents that match the query will be deleted. You can iterate through all documents in an index. You can get the metadata. So the metadata would consist of the index name, consistency level, the schema. Or you can activate a version of an index, so you can hot swap. So how do you index documents? Essentially, you access the index via the index name. If that index is not already in the cache or has not been created, you then create the index using the metadata, so specifying the index name and the consistency level. Once you have the index, you can index each document, or you can do a bulk index of all your documents. So the Java is pretty much the same, except for you're using the factory to get the index, to create it, and then you're using a builder to construct the metadata. Otherwise, you just, again, can iterate through the documents and index them, or you can do a bulk index. So as shown in the demonstration, we had some of the queries you support. So simple terms like hello, phrases, so where you care about the order and whether they're adjacent, logical searches using and or not, or you can restrict search to particular fields, like find all the comments written by Bob in this case. So you can do closed intervals, so find all comments published up to including the 1st of May. Or you can do exclusive ranges of open intervals, so find all the products priced between $100 and $200, but not including 100 and 200. So for search, again, you get the index. You search. You could either construct this query from some source, or you could just enter the string. In our case, we would have just taken the string the user entered, and then we would have get the search response. The search response contains things like the number of documents matched, the actual count of returned documents, the documents, and you essentially iterate through that response to get the results and get each document and their scores. The Java is pretty similar. Again, you get the index, you get a search response when you issue the query to the index, and then you iterate and get back search results, which contain, amongst other things, the document. Some of the other features that we didn't show in the demonstration were things like snippeting. So, in fact, this technology was sitting behind Wave as well. That here we have Sydney Karaoke is the query issued, and you say a snippet is basically giving you the context of where the best matches in the text are. And so, for example, here it found karaoke and Sydney together in a short segment of text out of this wave. And by default, it will give you back snippets up to 160 characters and at most 3 snippets, so that you can build some small representation of the document that you want to show in results. So to do snippeting, essentially you issue a search request, you have the query, and then you just indicate which fields that you want to snippet. So some of the other features are paging and cursors. So for paging, so typically where you give an index of the results onto different pages and people randomly access those results. So if I click on page 5, for example, then I have to give an offset. So if there's 20 results per page, then I'll want to start at result offset 100, and the limit will be 20. So there's a bit of a performance hit with this because it has to compute that set of results up to page 5 plus the next page. Alternatively, you can use cursors, which is much more efficient, which is like the next page or more mechanism that you see on a lot of websites. So cursors can be per result or per search request. So you can put links on each result, or you can put it on the whole page. So the first time you issue the request, issue the search, you'll specify, in this case, I want a cursor per page, so a single cursor, and I'll return 20 results. When they click on the next link, or the more button, or whatever, they will then get a response. You'll issue this request, which says, okay, this has the cursor here, and I want, again, I'll want another cursor for another next page, plus 20 results from that cursor. And then it's over to Bo.
All right. So once you get all the results, you probably want to show in the most relevant order to the people who are searching. As Jed mentioned, by default, we sorting by order ID. That is our either default sort, which comes pretty much for free because we store them in that order, or it is the sort that is being used even if you specify alternative sorting orders. So what you see here is the documents ordered by time, and I can change it. At the moment, this is a very simple application, so I can change it to author. If author is descending, I come on top, and then on the subsequent pages, Jed and Anonymous will appear. If author is ascending, then Anonymous bubbles to the top, and Anonymous, we made a lot of comments as Anonymous, so probably around page 3, Jed will appear, okay? But you can also do some more complicated sorting orders. The other way of, and I'm going to talk about it in a second, the other way of ordering documents is by scoring them. Typically, when you search on your website, you get documents that are most relevant. So, entertained. Let's search for entertained. So this is ordered by relevance, but we can, by relevance and time. But we can also have a simpler scorer, which is a hit count, which essentially will count only the number of hits. And in this case, they are inverted because simply the second phrase had more occurrences of "Are you entertained?" than the first one. So let me give you some more details on it. As I mentioned, the default order is order ID. If you don't assign anything to it, the number of seconds is assigned. So consequently, because we return documents in descending order by default of order ID, you get the freshest documents first, the oldest last. You can actually override this document if you know how to create an order from some sort of field to a magical integer, you're free to do that, and this will provide high performance and pretty much zero cost to your application. Alternatively, you can, in a search query, in search request, you can say, well, I would like to order somewhat different order, and you just provide sorting specification. You can sort on multiple fields. In this case, we are sorting by author, and the sort is descending. We also provide the default value. That means if we don't have the author in a given document, use this value, which causes the document either to bubble to the top or to the bottom. Once we sort them by authors, the secondary field is comments, so all documents with the same author, of course, go into the same batch, and then the secondary sort is applied. You can use somewhat more complicated expressions, so we just don't limit you to the individual field. You can use regular operators, of course, depending on what sort of fields you have. On numeric fields, you can use multiplication, addition. You can use conditional operators. If something happened, then assign this sort of score, otherwise assign this. And you can use a bunch of functions like maximum, minimum, logarithm, etc. Some examples here, if you want to sort by price plus tax plus shipping to give people the total cost of purchasing the item, you can do that. So you would include in a sorting specification expression, which is price plus tax plus shipping. Distance from a location. You can also construct artificial fields. This is probably not for sorting, but you can actually create artificial fields by concatenating a bunch of other fields. Along with the sorting, you also have access to custom scoring. You specify the custom scorer, and in this case, the expression is maximum number of tags. Count simply counts the number of fields that you have in a document with a given name. So it counts the number of fields named tag and limits it at 5. So then all documents with 5, 6, and 7 tags are considered the same. Everything else is sorted. If there are no tags in a given document, the default value is used, which is 0 in this case. With scoring, however, there comes a caveat. We have to score a lot of documents if you don't tell us how many, because we want to make sure that we return you the highest scoring document. So if you are requesting about 20 documents, probably limit to about 100 where you want to score. So just use caution. Don't go crazy on us. You can also use the default scorers. So we provide 2 default scorers, match score and hit count. Hit count is mostly for debugging. This is very simplistic. Match scorer is somewhat more sophisticated. So it uses the term frequency, TF, times inverted document frequency. So essentially, term frequency counts how many times the term occurs. And inverted document frequency counts is proportional to how frequent that term is on documents. So if you have the word the, which is in every document that you have in a repository, the IDF will be very low. And consequently, it will be scored low. Or if you have some terms that occur multiple times on only a few documents, then the score will be high. So this is a default one, and right out of the box. Hit count essentially is just TF. Snippeting, Jed already mentioned. We provide default snippeting, but you also can control it. So there is a snippet function, which rather than getting the defaults, you can say, well, the expression to return, essentially, a default snippet is also an expression that we return, but here you control it with a function, and you say snippet to return is based on field name comment. This time match just Sydney, don't match karaoke, and limit to 140 characters. The last parameter, 1, means you want a consecutive snippet, so don't take 3 pieces of a text. Here, just take a single piece of a text, so you can take 2 pieces, 3 pieces of a text, etc. per document. Okay, the original issue 217 actually was filed about data stores. So you might be wondering, what are we doing with all these documents? And the documents is essentially something that gives you full control. If you have data stored somewhere else in data store, you probably want to use documents. If you have concerns about privacy or revealing secret information or whatever, use your documents and create something that's searchable and points it back to the actual data that you want the user to find. However, if you store in data store, this is a section for you. So this is the second part of the architecture. Rather than operating on documents, you operate on entities. So now, rather than doing index document calls, you simply do entity put. And there are two possible paths. One is it goes to the data store and under the hood generates a document for you, stores a document, and in the document it remembers which entity it was generated from. Then we'll have appropriate way of matching that document with the entity when you execute the search. The other path uses task queue, which will allow you to actually do some extra modifications. So we also will give you the freedom to generate these documents freely without your intervention, but later modify them. Let me give you a more detailed description. By default, we are not going to change the behavior of data store entities. So if you have a data store entity, it has no full text search capabilities until you annotate the properties of that entity with search type. And in this case, I have the greeting, which is also this guestbook application entity. And the author is annotated with a search type atom, meaning we'll not modify it. We'll just take it as is without further tokenization. Comment, we'll take it, but we'll treat this as a HTML. And in this case, date is not being indexed at all. If you wanted the application like we had, you probably would have to annotate the date as well with type searchable, with a search type. And now you have these two modes. One is what we call a fully automatic mode. So essentially now you execute a put, and what happens is in the background we generate a document, we store it in Megastore, and remember which entity it came from. In order to preserve the same parameters, latency parameters as you had on data store, you can do it in two ways. You can either tells us just to put the entity, and in that case we'll just both write the entity and write the document on the same transaction. So either both are committed or nothing is committed, or you can say the search index mode is asynchronous write. What that means is we will generate the document, but we will return as soon as the entity has been stored in data store. In the background, we are going to start processing the document, and we'll guarantee the eventual consistency. So eventually the document will be committed to a full text search index. But it does not mean the moment you put call returned, you will be able to search using full text search. Depending on which one you want. You either want the same performance or immediate full text search, you can use one or the other. And there is a semi-automatic mode which allows you intervention. So in the most drastic approach, you say, generate the document, but don't do anything with it. Instead, give it back to my handler. So you specify search index mode none, which means we don't write it, we just generate it. And you specify the handler on which we'll call you with a serialized document. What that allows you is further modify the document. The application that Jed was showing you, for example, was analyzing the comment field and was extracting the hashtags and was extracting shoutouts. If you want to do that, this is probably the mode in which you would operate. There is also a semi-automatic mode, which is a combination of fully automatic and no write mode, in which case you simply allow us to write the document, but also give us a handler. What do you do with it? It's up to you. You can either monitor, log, whatever. The searching is done by providing one extra method, which is matches, which takes a query. And essentially the way it works is it goes to the document index, finds all the matching documents, and performs the intersection with other parts of the query. So it gives you only things that match the full text search plus other limitations you gave on a query. The final part is the REST API. We pretty much are going to follow the somewhat standard convention of noun selector, noun selector. All nouns are plural, selectors are IDs of either indexes or documents. So we, at the moment, we only have used 3 methods, get, post, and delete. Now, I have to give a caveat. This may change. This is very early stage of this implementation. If you say /indexes and you give us a get method, we give you metadata about all your indexes. The first selector is the index name. So on a get, you get the metadata about that index. On post, you create that index. The parameters of the index, like consistency and version, all that sort of stuff, you would specify after the question mark. On delete, you delete all documents from the index and delete the index itself. The second noun is docs. So if you execute a HTTP GET with /indexes A docs, you will get all documents from index A. Post method does nothing, and delete deletes all docs, but it retains your index. You can actually limit which documents you will delete by specifying further query after the question mark. So then, in that case, it means delete from A all documents that match given query. And the final selector is the document ID. So again, /indexes/A/docs.x selects the document X from onGet. On post, you create the document and you specify the fields after the question marks as a parameter. And on delete, you delete that specific document. Versions are supported by prefixing all the URLs with appropriate v1, v2, etc. As you might guess, at the moment it's like v.01, well, v1. Pagination is supported by offset limits, and format by appending the format name to the noun. In terms of a roadmap, I have to be very careful because Mick, our product manager, is watching me carefully what I'm going to say here. At the moment, we are just telling you what we are working on. It actually works, despite Mick's piercing eyes, it works. But we are going to invite you to give us a feedback. I mean, what is missing? What would you change? What would you like to see? A lot of you voted on issue 217. We hope that a lot of these people who are interested in full text search can give us a feedback before we completely nail the API. At the moment, it's fairly stable, but we still invite the feedback. The first thing that we're going to release is the core API. So this is the part that Jed was talking about, where you will have to generate your own documents and you will have the freedom of how you do it, but the additional programming expenses of having to do it. Subsequently, the data store API is going to be released, in which case you will then have these fully automatic and semi-automatic methods available, and further down the line is the REST API. Okay, to sum it up, you were given the overview of what is coming in a full text search. Standalone text search coming first. Full integration with data store, and a REST API coming next. And I guess we have 20 minutes, so if there are any questions, we just open the floor to the question. And please use mics on other sites so they get recorded. Yes?
All right, so I have an app that has many different customers in the same data store. All of my entities are keyed on the customer ID field, and I search on that in all my queries. How do I do the same thing with full text search? Do I use the thing to make multiple indexes, one per customer? Do I also add the same kind of field to all of my full text search queries? What's the right way to go about this? Will there be a multi-tenancy namespacing API added onto this? How does that work?
So the recommendation would be to indeed have an index per customer, because you have the freedom. I mean, we don't limit how many indexes you have. There is, at the moment, there are some rudimentary limits put in place that you cannot create millions of them in one day, because then we think that there's something wrong with your application. But in order to fully isolate them, I would recommend using customer name or some sort of thing that identifies the customer as the index name. The reason for that is, and I didn't mention it in the talk, we also plan to allow you, if the customer says so, make the given index accessible to other applications, right? So you can search it through other applications, and then it would be easier just to give that permission per index rather than having to juggle all these things. So there are, as far as we are concerned, you can have thousands or tens of thousands of indexes. So
okay, but that will require using the lowest level interface to the search.
Yeah.
I can't just go with my data store object as they are.
No,
So
at the moment, yes, that's a fair comment. I know we can think about it, how we would do it, but there are some limits. I mean, at the moment, we actually, on the data store integration, we want to return you all entities of a given type. And so,
yeah. No, that's fine. Sounds pretty easy to go that way. Thanks.
Yeah, sure.
A couple of things. Do you have the ability to mark fields, certain fields as more important in terms of the scoring?
Jed?
There is, field match boost. So you can put, there's boosts for field matching. Yeah.
And then fuzzy matching for misspellings?
Okay, so we do stemming synonyms and diacriticals, but this is done at the query time. So if you want to match something, prefix matching or fuzzy matching?
Yes.
Okay, yes. So I'll say yes to the first half. Essentially, our approach to stemming synonyms and diacriticals is that it's better to do it at the query time because these things change. We actually live in Australia, and there was like a Kevin 07 was the slogan, right? And it's if you enter two terms, Kevin 07, then we in 2007 would have realized that you are talking about a particular guy, Kevin Rudd. Probably in 2004 it was not relevant. So you don't want to recompute your index based on a year, what is popular in a year. So this additional processing is done during the query time. However, at this time, we don't have anything that allows you to say anything that starts with foo and give me all these results. So yeah, that is one of the actually more requested text search API features, but we haven't quite nailed it at this point.
So this question is about the data store text search API. So if you have an entity in Java or in Python, you have this, what fields to be searched part of the metadata, either as annotation or probably in Python you say HTML search sort of thing. How do you do that for low-level APIs and probably expander models of data store?
At the moment, we just allow you to do the annotations on fields, right? But in what expander models?
And low-level APIs, you use hash maps?
To be honest, that part has not been implemented. So if Max is anywhere in the audience, he can probably guess the answer, but at the moment.
So this REST API, what's the objective? Is it directly going to be exposed as HTTP request for the browsers, or is it going to be only used within the context of my application? And if so, can I get only the pointer, which is the ID to the entity, and I'll have to refetch the entity again from data store? What is the response of the REST API? I have two parts, right? So
okay.
The front end from the browser, and the second part is, do I get full entity data, or should I have only the pointer which will redirect? I have to get it from the...
Again, I can tell you what is at the moment. So just a document, you get the document, and the main purpose of REST API is to allow you to use what hopefully is the goodness of our text search API, even if you don't have an App Engine API, application, right? So I'm not sure if returning entities makes sense on for application, because it's meant for application that is not necessarily a App Engine API application. So
you mean the browser or inside the applications, App Engine's container?
No, if you made the request from a browser and we gave you a full entity and you didn't have a App Engine API, App Engine application, I know what
you will have authentication problems.
Yeah, that's sort of, I mean, authentication is a totally thing. This is going to follow the same principle that TaskQ was following.
Okay.
So
As an administrative API.
Yeah. Yes. Okay.
You talked about page ignition and cursors, and I'm wondering if I'm using a per document consistent index, and I do a search, are those, the cursors and the page ignition, is that based on a snapshot of what the index looked like when I did my search, or if things are being added to that index, is it going to bump my search results around?
The pagination will be recomputed, so, for the pagination will be recomputed, but for the cursor, it's a good question. I think it's actually, we'll take it from where it was at that time.
Well, yes. I mean, if you change the document, if I understand you correctly, if you change the document, it will not impact it because the document ID stays the same.
No, but if you added more results.
Will it?
So for the first case, when it's using pages, it's going to recompute the whole thing anyway. But for the cursor, I'm not sure what happens actually.
We should have tried it.
Can I send you an email and get back?
Yeah,
Sure.
So I heard about Python and Java. How about Go?
We didn't talk to the Go people.
They sit next to us, so. Yeah.
Well, yes. We'll politely ask them to do that. I mean, our backends are agnostic. You know, we just use RPCs and we just return protocol buffers. So hopefully they can create the appropriate Go object from it. Essentially, what you see is there is an RPC, and in front of it sits a thin layer of Java API or Python API that reconstructs the Python object or Java object. So I don't anticipate it's going to be a major hassle to get a Go going.
Another question about data cursor. I noticed in your examples they were all next page.
Yeah.
Can you go to previous page? You know, like using the data cursor?
You could, but you would have to store it yourself, right? So we always give you the next one. If you store it yourself, you can actually do this. So essentially for us, the way we store documents in Megastore, the cursor tells us the row from which to start scanning. That's all it is. So if you have it, we can start scanning from earlier row, but in HTML applications, kind of difficult because then you have to if you own page 5, you have to maintain cursors from the first 4 pages. So this is why we actually, the application uses cursors, but rather than using paging. So because we found out that we had to maintain them and all that sort of stuff. So
is there a general solution for that? Like everyone has to do it themselves, and you're saying you have to maintain all of them, but what if somebody, you have a thing that says page 1, page 2, page 3, and they just want to jump to page 6, and I haven't gone there before, so.
Yeah, so in that case.
In that case, you're not using cursors, so you're just using offsets. So you don't need to record that. You just have you give the page number and the actual size of the page, so that you can randomly access pages that way.
Okay.
On the data store API, is there anything for including reference properties in a document?
Not at the moment, but again, valid remark. We probably could just do it by keys, right? So you could then extract the documents by keys. At the moment, we didn't implement it, so no. But well,
like if you have a user reference property that most people might want to search by user.
Yes, that would be somewhat complicated. We would have to do multiple traversal of the index. But by all means, send us that feedback, and if we find that data store magicians can do it, why not?
Thanks.
I have 2 questions. The first question is related to the index space. How do you configure it, and can you monitor it?
I mean, you will have in your admin console ability to look at all indexes that you have. So there will be a list of all indexes your application has, and then once you drill into an index, you will have the metadata and
things like sizing.
Yes, size of an index. I mean, at the moment it's not real-time updated, but it's probably going to be, like 6 hours lagging basic statistics about the index, something like this.
One other question, probably related to the site itself. Like, are there any thoughts on sharding and aggregation?
Not sure. I mean, so we actually sharded internally. I don't think this is part of an application. So once your index grows large, it gets spread over multiple, what we call them, tablets. So we don't want you to do it explicitly at the moment. It is done under the hood.
And by aggregation, you mean things like, in the case of a user index, like an inbox, you want to be able to search all inboxes, over all inboxes or something like that. Is that what you mean?
In terms of, like, when you shard, you would probably want to search across the shards and aggregate the results and send them.
Yeah,
so
it's already handled, yeah.
The add-on type, is that just a short word for the untokenized type?
Yes. Yeah.
So you can, I have these weird preferences of having words of the same length. So the first 3 that we did was text, date, and then atom. They all had 4 characters.
If you have a field that can change after the document's indexed, do you have to re-index the whole document? Say like a user tagging the document.
Yes, currently you do.
Yes.
Yes. I might have missed this, but when's it available and when will the documentation be updated?
Where's the person who, like,
hiding down the back
if
there.
you see like a red mark on my chest, whatever I'm answering, that means I'm answering wrong, because no, he actually is in back because he's got a really long rifle. So apparently we are supposed to say we are working very hard. It actually works, right? What you saw was no smoke and mirrors. But there is few production issues that we need to push through. And
you do a pre-release on the local before it's running the days, or like you've done for some of your other stuff?
Again, I have to judge his eyebrows from a distance. It's all going to be announced, and Mickey is going to kill me if I, just one wrong word, I'm dead. Yeah. Sorry, I know it's not a satisfactory answer, but this guy is scary.
I just want to say thank you. I love it. Thanks for doing it.
Thank you.
I want to ask about the sorting algorithm. How about proximity search? For example, I have 2 documents, A, B, C, or A, C, B. If I am searching A or B, the TF-IDF of both documents are the same, but can I get the ABC first?
That's a good question. I'm not sure if that scorer does that as well, but is proximity in the back end?
I don't know. That's my answer. It's a very lame answer, but kind of honest at the moment. So yeah, good feedback. I mean, if you can just either add it to issue 217 or something like this, I mean, we definitely...
We're aware of proximity search, though, but whether it's actually supported in that score, I'm not sure.
Yeah. Yeah. All right.
For a different kind of proximity, the description for this session mentioned geo search.
Mm-hmm.
Is that, how does that work?
So you record a point, so you can create a field which you specify that this is a location, and you need to specify the longitude, latitude for us. And then there is a function which is a distance, and so you can search by anything that has distance less than 10 kilometers and give it a higher boost. So I don't know how you would use it, but you can use all these functions like greater than 10 kilometers, give it 1. Otherwise, give it miles, and give it 5, right? So, or you can just sort by a distance from a given point as well.
Yeah, but you can use it as a restrict in your search as well as sort by the distance.
To prioritize it, to sort
Yeah,
it.
exactly.
Yeah, but when you search, we use a stupid thing, which is we assume that you can fly. So,
Yeah.
so, yeah.
All right. Thank you.
Yeah.
Thank you.
All right, I think that's a wrap. Thank you very much.
Thank you.